Hi everyone, my name is He Jing. My final project will continue working on the building facade of Q1 Sassoncraft Quarter Essen. I was not able to dig into details for the curtain panels in Project 1, so this time I'm going to look at two issues: to change the family type of the panel patterns and to control the rotation angles of the blades by the sun direction. Now I'm going to look at how to generate different panel types on the building facade. First, I created 4 types for the curtain panel pattern, and here's the first type, where the lengths of all the blades are the same. If I change it to another type, you can see these numbers are changed, and if I apply it, so here the lengths of all the blades are changed, with the length of the shortest and the longest blade controlled by these two parameters here. These are the 4 types of patterns I created. I'm going to use this elevation wave to show the panel changes. First, I created this Excel file. So these numbers will be used to generate the panel types. And then let's bring Dynamo here. So the main idea is first to select divided surface families, and then create a list with all the 4 family types, load the Excel file, read the test, and then here I used the Python script from one of the examples in the lecture. Also, I changed it a little bit to make sure all the 4 family types are included. Then I use this package called change family type to complete the change. So if I run it, okay, here you can see the change in the family types. So like this one is all the same length, while in this one it shows the difference. So this should be type 0, 1, 2, 3. The next step is to control the rotation angle of the blades by sun direction. 2 issues I need to pay attention to. The first one is that I need to get a projected vector for sun direction so that I can get a right angle to control the rotation of the blades. The second issue is that if you look at those diagrams at the bottom carefully, you can see only the blades on the facades that facing the sun direction will do the rotation to block the sunshine, while the blades on the facade that is not facing the sun will stay perpendicular to the building faces. So I will use top wave to show the rotation. Here to get the normal vector for the faces, and this part getting the sun direction vector, and by using the x and y coordinates, I generated a new vector which worked as a projected vector for the sun direction. And I calculate the angle and the dot from the normal vector as well as the projected sun direction vector. This angle will be used to calculate the rotation angles for blades on all the sides, while this dot value will be used to decide the blades on which side will be rotated. So this list is for the final rotation angles. As you can see, I only calculate the 3 sides. Blades on this side will be 90%, while this side for about 45, and this side about 44. And then, since there are 12 units on each side, I repeat this list by 12 times. And by doing the transpose, I finally got 12 rotation angles on each list. Here the same thing, I get the divided surface families. And then from this list, you can also see 12 items on each list. And I flatten both the lists and also transform the degree to radians. Finally, using this set parameter by name, I was able to change the angle of each blade. Now if I change the position of the sun to the afternoon and then hit run again, Okay, so here you can see the panels on the west and south side are rotated to block the sun. Finally, here shows how rotation is going to work with the change of sun direction. That's all for my final project. Thank you.